Something new just showed up in our solar system, and it's definitely not from around here. It's a visitor from another star, hurtling through our cosmic neighborhood at around 137.0 miles per hour, and scientists have named it 3I, Atlas. And get this, it might just be older than the Sun itself. This is only the third time in history we've ever confirmed an interstellar visitor, but this one is already breaking the mold. It's active, it's puzzling, and it carries the chemical signature of a part of the galaxy we've only dreamed of studying up close. So, what secrets is this ghost from another star system about to reveal about our own place in the cosmos? It all started on July 2025. In the high, arid desert of Chile, a robotic telescope designed to spot incoming asteroids found something odd. A pale, silent dot was moving with a purpose that just screamed alien. Astronomers were scrambled. The object's path wasn't the familiar loop of an orbit tied to our sun. Instead, its trajectory was a sharp, open-ended curve, a hyperbola. That was the smoking gun. It meant the object was moving way too fast to be caught by the sun's gravity. It came from the space between the stars and, after a brief visit, it's destined to return there. Confirming it wasn't easy. The comet was spotted against the glittering star fields of the Milky Way's core, like finding one special grain of sand on an endless beach. But by digging through archival images, they traced its path and confirmed it. 3I Atlas was officially our third interstellar guest. So, what exactly is this thing? The 3I in its name literally means it's the third interstellar object we've ever spotted. First came 1I, Oumuamua in 2017, a bizarre cigar-shaped mystery. Then came 2I, Borisov in 2019, which looked and behaved much more like a classic comet. 3I, Atlas is in a league of its own. Unlike the quiet Oumuamua, this visitor is clearly active. Images from telescopes like Hubble and Gemini North show it's wrapped in a fuzzy cloud of gas and dust, a coma. That's the classic sign of a comet. As it nears the sun, its surface ice is turning directly into gas, releasing ancient dust. The exact size of its icy core is still a puzzle. Early estimates were huge, but recent Hubble data suggests it's less than 5.6 kilometers, or about 3.5 miles, across, and could be much smaller. Its incredible speed suggests it wasn't just gently nudged from its home system. It was likely thrown out with tremendous force, maybe by a giant planet or a close call with another star. Here's where it gets really mind-bending. The secret isn't just what it is, but where and when it might have come from. One of the leading hypotheses is that 3I Atlas hails from a region of our galaxy called the thick disk. Think of the Milky Way as a huge city. Our sun lives in the thin disk, the flat, busy downtown. The thick disk is like the ancient sprawling suburbs, a puffed-up region full of the galaxy's oldest stars, some of which are up to 10 billion years old. Our solar system, for comparison, is a youthful 4.5 billion. If that's right, 3I Atlas could be a planetary building block from a star system that formed billions of years before our own. It might have been wandering the frozen void since before the Earth even existed. We could be looking at a perfectly preserved fossil from the galaxy's past, a cosmic time capsule delivered right to our doorstep. Because 3I Atlas is so active, it's a scientific jackpot. For the first time, we can get a detailed look at the chemical recipe of an object from such an ancient part of the galaxy. The initial findings are already delightfully strange. Observations have confirmed the presence of water being released into its coma, a lot of it, surprisingly active for how far from the sun it is. But what's weird is what seems to be missing. Early observations haven't detected some common gases we expect to see in comets, like cyanogen. This has sparked a debate with two cool possibilities. The first idea is that billions of years in deep space have baked its surface into a tough, tar-like crust, trapping more volatile gases underneath. As it gets closer to the sun, that crust might break, and we'll see what's really inside. The second idea is even bigger. What if the comet just doesn't have those elements? Its ancient origin in the thick disk could mean it formed when the galaxy had fewer heavy elements like carbon. If 3I, Atlas, is truly carbon-poor, it would be stunning proof of how the galaxy has changed over billions of years. We'd be seeing a truly primitive object made from the raw ingredients of the early universe. This journey to understand our place in the cosmos is fueled by discoveries just like this one. If you think this stuff is as cool as we do and want to join us on more deep dives into space, go ahead and subscribe to the channel and ring that notification bell. Your support helps us keep telling these incredible stories. So, what's the big deal? Why does the chemistry of one visitor matter so much? Comets are leftovers from when planets formed. They're the icy bricks that never made it into the final building. The comets in our own solar system tell us about our own origins. By that same logic, 3I, Atlas can tell us about the conditions in its home star system, a system that may have vanished eons ago. For decades, we've only studied the building blocks of one planetary system, ours. Every rock we've ever visited is, in a way, family. 3I, Atlas is a true outsider, with a totally separate history. It's like an archaeologist who has only studied Roman ruins, suddenly being handed a perfectly preserved tool from an unknown, more ancient civilization. The potential for discovery is off the charts. Scientists are in a flat-out race against the clock. 3. Atlas is just passing through. Its closest approach to the Sun, or perihelion, will happen on October 29, 2025, when it passes just inside the orbit of Mars. As it gets warmer, its activity should ramp up, hopefully revealing the deeper layers of its composition. All eyes and telescopes are turning its way, but the MVP will be the James Webb Space Telescope. With its incredible infrared vision, JWST is perfectly suited to sniff out the gases coming off the comet's core with amazing precision. Its observations, which began in August 2025, could finally solve the mystery of its weird chemistry. After its brief, fiery pass through our neighborhood, 3I, Atlas will head back into the cold and dark. It will never return. This is our one and only chance to study it. From a single faint dot of light, 3I, Atlas has become one of the most exciting astronomical discoveries in years. It's more than just a comet, it's a messenger from a lost era of our galaxy's history, a real piece of a star system that could be billions of years older than our own. It's carrying the chemical story of a different corner of the cosmos, forcing us to rethink how planets form across the galaxy. The discovery of Oumuamua, Borisov, and now 3I, Atlas proves our solar system isn't an isolated island. We are constantly being visited by travelers from other stars. As our telescopes get better, we're going to find more of them. Each one will be a unique scientific treasure, another piece of the giant cosmic puzzle we're just starting to put together. The story of 3I, Atlas is still unfolding, but one thing is clear: our view of the galaxy will never be the same. So, what do you think this ancient visitor can tell us? What secrets do you believe are locked away in its ancient ice? Let us know your thoughts in the comments below.